Good morning and welcome to your intermediate algebra notes. Today we're going to look at slope and direct variation just briefly. This lesson we're flying through. You will not even get homework on this, but I just wanted to make sure that you're familiar with these. So chapter 4 section 2 is slope, and then it's going to talk direct variation. And the main ideas on that are we're going to know how to write and graph direct variation equations, which means you're going to know what direct variation means. And in plain, simple terms, direct variation simply means that one of the 2 points has to go through 0, 0. You're going to have another point, but one of them has to go through 0, 0. So that is probably the most important thing about direct variation problems. So we'll solve some problems with those. So just like I said, direct variation just means you know for a fact one of your points is 0, 0. Excuse me, your constant of variation is your slope. And the family of graphs that you're going to get from that, if it's truly a direct variation problem, no matter what we're going to do, every single graph, oh, I missed, is going to go through the point 0, 0. So every single one in the family of direct variation linear equations is going to go through 0, 0. And the parent graph is y equals x. So this one just says name the constant of variation for the equation, then find the slope that passes through the points. So your constant of variation is the number that goes in front of x, and what I just told you is that's the same thing as your slope, because if I count here up 2 over 1, my slope is 2 no matter what. So that is what you're going to be looking at if you ever get anything direct variation related, and they go through and they're going to calculate everything that way, but we don't need to worry about that one. So then this one, same thing, name the constant of variation. So if I look at this right there, I would say my constant of variation is -4. That is my slope, but if I want to verify it, counting 1, 2, 3, 4, down 4 over 1, my slope is m equals -4, down 4 over 1, and it does indeed match. So they're gonna, again, do the math on the whole thing between the 2 points to get it, which is legal. And it is fine. So on this one, hopefully look at it, look at your equation. So constant of variation and slope, I am looking for one where they're both the same. And so I hope you choose letter B. There you go. Next one, again, equation is y equals -3x. Constant of variation should be the coefficient in front of the x. Should match slope. So hopefully you say letter D. Then the next thing they're going to do is just make us graph an equation with this. So notice constant of variation is 1. There is no number added or subtracted on the end. So I would start at 0, and then my slope is up 1 over 1. There I go. Up 1 over 1. Or I can go backwards 1, down 1. But no matter what, there is the equation of that line. And I have it right there. So on this new one now, we've got this equation, y equals -3 over 2x. So oh, that's interesting. We know that this is our slope. So my slope is -3 over 2. Again, there's no y-intercept given. So I am going to start at 0. And if you remember from slope, this is your rise or run. So according to the way I have it written right now, I'm going to drop down 3 and go over 2. So drop down 3, go over 2. I can do that again. Drop down 3, go over 2. You want to try to count consistently. If you run out of room like I have here and you want to go the other way, your negative sign can flip-flop back and forth. So I could do that as 3 over -2. So I could go up 3 and run backwards 2. And that's the equation of that line. So that is a direct variation there. All right, doing this one relatively quickly, we've got y equals 2x, so my slope needs to be 2, positive 2. So looking at these graphs, since we've already talked about slope, I know that the graphs of letter A and D, those are falling. They are going downhill. They have a negative slope. So it is not A, it is not D. So I need the one that rises up 2 and goes over 1. And so my pick is letter B, because C is up 1 over 2. That is a slope of 1/2, not 2. So there's the error there. This one now, I know it needs a negative slope because it has negative 2/3 in front of the x. So it's got to be one that falls. So it is not A, it is not B. And now I need one that drops down 2 over 3. If I check this one, this is, if I go with it, here's down 2, but it does not go over 3. It should be over there. So it's not C. D is the one that does match that system. So that's what I am going to say for my problem there. So essentially, here's just a little summary of what direct variation means. It means it's always going to be y equals kx. It's going to go through the point 0, 0, and k is going to be your slope in front. So that is your main summary there. Now, occasionally on standardized tests, they're going to make you do something like this, and this does show up. I've seen it on the MCA. So I just need to make sure that you know what to do if you ever see something. It says, suppose that y varies directly as x. That phrase, all it means is that is a direct variation. So I know I'm dealing with y equals kx. And why they use k, I don't know. It's the same thing as saying slope of x. So y is 9 when x is -3. That means we have the point -3, 9. Because remember, this is always x, y, always in that form. So your slope, the first thing I want to find is my slope. Well, I can either graph this and count, or I can do what they were doing a moment before. I know that one of my points has to be 0, 0, if it is a direct variation problem. So slope is y minus y over x minus x. So y minus y over x minus x. I'm going to go 9 minus 0 over -3 minus 0, which is -9 divided by 3, or -3. So this is for slope. So my slope is -3. That means when I come over to write my equation, it's y equals -3x. And we are done right there. Now, I don't know if you notice this, but there's a much faster shortcut. Since this point is always going to be 0, the second point is always 0 no matter what, well, I can just take y divided by x, and it will always give you your slope. So 9 over -3 will give me -3x. If I use that as my shortcut here on the next one, let's see if we can go with this. Oh, it's going to put those words on. Sorry. Now we'll do this one. So we want to know, oh, this is just to solve this one. Use that equation to find x if y is 15. So, well, I knew my equation was y equals -3x. So y is going to be 15. I'll put in 15 equals -3x. So divide off my -3, and x is going to be -5. What I wanted to do, though, was this shortcut. Here we've got a direct variation, and I know that y is 15 when x is 5. So if I want my slope, it's y divided by x. So 15 divided by 5 is +3. So I just need to look at the equations. That is the one that lists my x value as, or my slope value as being 3, and that is my pick. And so this will be very much the same. If we've got y equals 3x as the equation, this one just says, now figure out what it's going to be when y is -45. So if I put in -45 equals 3x, I divide off my 3, and I get -15 is equal to x. So it should give me letter C, number 15. And now at this point, we're going to call that done.